Hi, this is Lori, and this is my homework for Paul McWhorter's Uno R4 class. This is for lesson 12, and we're reading analog voltages in this lesson. We're supposed to use a potentiometer to dim an LED for this homework. Now here's my circuit for this homework. I'm not using the potentiometer we got in our kit. I'm using a what's called a slide potentiometer, and I had a chance to use this when I did an advent calendar over the holiday season from Pi Hut. And so I went and picked up a couple more to have for just this kind of purpose, playing around with. They're very easy to move. You just slide it back and forth. So very easy to adjust, much better than trying to twist that little knob. So I'm really pleased with that. But I did run into some challenges using this. It's supposed to be a linear one, at least it was advertised as linear. But I found as I moved this slider across, going from 0 up to 1023, I marked here on the scale when I kind of got to various settings. So each of these represents a quarter of the scale, but you can see that 50% of the scale is right here in this little narrow range. So it's pretty linear in between here, but it's sort of non-linear on the ends. That may be the way potentiometers typically are. I don't know. But that's, in my opinion, that's kind of a nonlinear response. And I would have expected the same amount of distance to be the same amount as I went across. So I have kind of a nonlinear response from my potentiometer. And then we also know that perceived brightness is also nonlinear to our eyes. So I tried a lot of things to try to make this brightness change in a linear fashion as I moved the slider, and I was mildly successful with what I came up with, and I ended up with a pretty heuristic equation to kind of deal with this scale and the fact that the perceived brightness is also not linear. So I'll show you next what I did for that. So I ended up in an Excel, and I started just thinking about segment type models where you kind of chop up your X range into segments and then fit a very simple equation in between. It allows you to do like a nonlinear model, but still use sort of linear equations in the smaller space inside of each segment. So I decided to divide it up in 4, and obviously you could get better and better if you were to divide it up into more and more segments. Then you could really follow whatever kind of crazy nonlinear trend you had. But what I was noticing is I kind of wanted to, as I read in the first, I kind of divided it up into 4 quadrants. So in the first quadrant, I wanted to increase the brightness that I was giving to the LED pretty quickly. And then over that sort of linear range, that middle range, I wanted to change pretty slowly. So I wanted a slope that was less. And then over that last range, I wanted to change the brightness a lot. So I went, as you can see here, I went from 70 to 150. And I found once I started giving more than about 150 to the LED, it just didn't really change in brightness that much. So there wasn't any reason to go to 255, so I stopped at 150. So I'm just using Paul's things he's always taught us, to how to get the slope and intercept from 2 points, and that's what I did. And I created this little spreadsheet so I could kind of play with it until I kind of got the response that to my eye looked roughly linear as it was changing. It was very hard, this initial part and the end part, to really get it to a linear look, but I decided I needed to stop playing with it, and that this was a suitable enough solution. Yeah, I mean, I'm sure there's some driving equations that we could use, but I think once I had the nonlinear potentiometer along with the nonlinear brightness, I think it got pretty complicated. And I don't have any way to measure what I'm seeing with my eyes. So that would be the other thing. If I had access to something like that, maybe I could actually develop a real equation besides kind of this heuristic type equation that I've got here. But it works, and that's the great thing about heuristic models, is sometimes they just work. Well, let's see it in action. Here is the code that I put together. It's pretty straightforward. We set up our pin for the LED and our potentiometer and all the other things that we'll need. And I'm going to calculate brightness using that 4-segment model. So I'll start off with it being a float, but we'll have to pass an integer version of this into the analog write. We'll set up our pin modes, and we'll set up the serial monitor as well, so we can print the results to the screen. We'll read the potentiometer, and then here's sort of my heuristic equation, I call it. So it's a lot of ifs and elses, but it works. So yeah, if we read less than 2, we're going to turn it off. And then if we're less than 256, we'll use this equation, and get into the next quadrant, we'll use this one. And you can see for the middle 2 quadrants, I ended up using the same equation. And then this is for the last quadrant here. So that's how I calculated brightness. And then when I pass it to the analog write, I'll just turn it into an integer. And then I'll print out the potentiometer reading and the brightness in the float scale rather than the integer scale. All right, so let me get it connected up and we'll see it go. Okay, we kind of have the lights dimmed down a little bit, although the iPhone really makes the most funny light it sees. I'm going to try to angle this just a little bit more towards the camera. And let's give it a go. So you can see the reading in the serial monitor. We're got a 0 and a brightness of 0, and you can see I'm going to slide it a little bit up, and you'll see it come on. And then I think if you look at the whole diffuser, you'll notice it filling up with green. And we're almost, we're right at halfway now. And could use a little more fine tuning, I think, because we get most of our brightness in the first part of it. But it actually is changing a little bit more than it shows on the screen. Because I think the iPhone is compensating a little bit for the lack of light on it too. So there's another nonlinearity that we're faced with when trying to film this sort of thing. But in person, I'd say it's pretty decent. It could use a little more. The upper end could be a little less, get a little bit more change between here and here. It changes some, but not as much as I'd like. But it was time for me to quit spending time with it. My husband was staring at me wondering, why am I spending so much time playing with this little slider thing? But yeah, it's very interesting, and I finally got a chance to use this slider, but I really like them. They're just so much easier, and they're more fun to play with, I think, too. So much easier to turn. So we'll see what else I can do with it. Well, that's my homework. And thank you, Paul, for the great lesson, and thank you for watching.